Guys, and welcome back. This is our last topic of this unit, so we'll be testing this week actually. So make sure you review over all your notes. If you have your law of exponents chart, which I placed in Thursday's folder of last week, you should definitely download that, print it out, and use that for your test, okay? So we are going to simplify radicals, so it's super similar to just factoring out. Radicals are square roots, cube roots, all of that stuff. So some things that you should know already are the perfect square roots. So like 25 is a perfect square root. I get 5. 36, I would get 6. 49, I would get 7, like that. But we're looking at the numbers between. So what about the square root of 26? What about the square root of 53? We want those numbers. So this is how you do that. No, you cannot use a calculator for this. It'll give you a decimal, and that's not what you want. You want a simplified version. You want the most exact, because radicals that don't give you an exact number are irrational, and we want as exact an answer as we can get. So let's jump right in. First thing you're going to do is write down these steps. So we are breaking down numbers into factors. We are identifying the index, we are grouping by the index amount, and we are putting them in front of the radical. That sounds weird. So I want you to draw out this picture. So we have our coefficient, which is in front. We have our radical, which is our symbol. It looks like a little check mark division house. The index is the number right in the check mark. That tells us, are we taking a square root, cube root, fourth root, fifth root, what root? And of course, inside, that is a radicand. So the index, if you don't see an index, it's a 2. I know we're used to invisible 1s, but this is a 1 time where we will have a 2 instead, okay? That's why it's normally just called a square root. So let's jump right in. Okay, so we want the square root of 25, which we already know is 5. I'm doing this since we already know this answer. I'm doing this so you can see how the steps work. So our first step is going to make a factor tree. So 25 can be broken down into 5 and 5. So I'm going to rewrite my radical with 5 times 5. I've broken it down. I've also circled the 2 so you can see that I want pairs. I'm looking for a pair of 5s. In this radical, I have a pair of 5s. So I'm going to take those and I'm going to make it 1 5 and take it out to the front. And then I have nothing in my radical. So we just get 5. The reason why we're writing 1 5 is because I want to know what number did I multiply by itself? Which number did I multiply more than once? And it was 5. I didn't multiply 5 8 times. I multiplied it twice. So I just write the 5. Okay, so example 1. Let's look at the square root of 12. So same thing. We are going to make a factor tree. So 12 becomes 3 and 4, and you could have done 6 and 2. It's your choice. So 3 and 4, 4 breaks down further into 2 and 2. So really we want the prime factors. So I'm just looking at 3, 2, and 2. So I'm going to rewrite my radical as 3 times 2 times 2. Again, I'm looking for pairs because this is a square root. So I see that I have a pair of 2s. So I'm going to take that out and put it out front. I'm going to say that I took the square root of 2, which I took the square root of 4, it was 2, and inside I was left with a 3. So this would be my final answer. We want it as simplified as we can get it, and that is as simplified as it gets. 2 square root 3. That's it. So let's do a bigger number. Example 2. And what if we have a number out front already? So I went ahead and broke this down already for you. So I'm just going to go ahead and rewrite it. So 2 square root inside, we have 5 times 5 times 3 times 3 times 2. So this is the prime factors of 450. Also, if it's easier for you, you could just do 25 times 9 times 2. If you know your perfect square roots, that's great. You can do 25, then 9, and then all you're doing is taking the square root individually. However, because I know some of you don't know all of that, we're just going to stick to the pair thing. So I want a pair of 5s and this pair of 3s. I'm going to stick them both out front. So I end up with 5 times 3 times 2. So anytime I move something outside is being connected by multiplication. So 5 times 3 times 2. And there's my factor tree so you can see if you get stuck on the factors. And I don't know why I mixed this up. Sorry. Okay, so 5 times 3 is 15, times 2 is 30, and then square root of 2 is left. And that is my final answer, 30 square root 2. Okay, next one, example 3. We're given a square. We want to know what is the length of the side if the area of the square is 175. You will have a question like this on your test. Super similar. It's got a little bit more of a bigger number, so be careful. So square root of 175, we're gonna break that down. So the factors of 175 are 5, 5, and 7. Let's put that in the radical. So 5 times 5 times 7. I do have a pair of 5s. So that pair of 5s is coming out, and I'm just left with the square root of 7. We didn't go over cube roots or fourth roots or anything like that because you're not going to be tested on those this week. And I feel like this is kind of enough to focus on. So we can just stick to what we know, which is this. Okay, so good luck. If you need any help, email me, get on Zoom, ask for help. Okay, bye guys.